Alright, so this is part 2 of our chapter 2 section 4 notes, and we're going to be looking at synthetic division. Now, as we move on in math, synthetic division will be much more useful for us, but again, like I said in the part 1 video, it only works for things that are linear factors here. If I have an x squared here, then I have to use long division. So let's go ahead and get into actually dividing here. Now with synthetic division, we're only working with the coefficients. And notice here we have a 5 and then we don't have an x squared term. So just like with long division, we have to have a placeholder here. And we're dividing by x plus 2. Now we're going to line up the coefficients here. So I have a 5, placeholder of 0, 6, and then 8. And we're going to put a little box here by what we're dividing by. Now we're dividing by x plus 2, but we're not going to put x plus 2 here. We're going to set x plus 2 equal to 0 and solve for x. And now we're going to go through the process of synthetic division. Now you might have to watch this first example a couple of times to really get the pattern down, and that's okay. But I think once you get the pattern down, you'll like it better than long division. So the first thing we do is bring down our 5, and then I have negative 2 times 5 is negative 10. Then I'm adding 0 plus negative 10 is negative 10. And then again I'm multiplying here. Negative 2 times negative 10 is 20. Then I'm adding 6 plus 20 is 26. And again I'm multiplying. Negative 2 times 26 is negative 54. I'm sorry, 54. Okay. Oh, I'm sorry, it's 52. What am I thinking? It's negative 52. And now we add 8 plus negative 52 here. It's going to be negative 46. 44. I can't do math right now. Negative 44. And this last term here is our remainder. Okay, that's our remainder. Now these other terms here, these are the coefficients of the next term. So if this is the remainder, then this is our constant or our number. This is our x term. And this is our x squared term. And if there's another number over here, that would be our x cubed and so on. So our answer then is 5x squared minus 10x plus 26 plus, and just like before, our remainder over what we divided by. And that's our answer. So I know that was kind of a lot, and I messed up a couple of our numbers here, but you may want to go through that process again. So let me just talk about it briefly again. We brought our 5 down, we multiplied negative 2 times 5 and got 10. Then we added, then we multiplied, then we added. So the way I think about it is my diagonal lines here are my multiplication. So negative 2 times 5 is negative 10. And then we have bringing our addition vertically here, 0 plus negative 10 is negative 10. Then again, negative 2 times negative 10 is 20. Then add, then multiply, then add. Okay, so that's the process that we're going to go through. Now let's do one more example. So we have 2x squared minus 11x plus 5, and we're dividing by 2x minus 1. So my coefficients, I don't have a placeholder term anywhere. And I have my box. And 2x minus 1 equal to 0. Add 1, divide by 2. X is equal to 1/2. And a lot of times people get nervous when we start to see fractions here, but it's not going to be too bad. We bring down the 2. 1/2 times 2 is 1. And now we have negative 11 plus 1 is negative 10. 1/2 times negative 10 is negative 5. And 0. What that means is that this divided evenly. Okay, so that means this was a factor. So what that means then is this is my number, this is my x. We have no further terms, so there's no x squared. So my answer then is 2x minus 10. And that's it. At the bottom here we have what's called the factor theorem, and this will be useful for us in the next couple sections, so you want to make sure you remember this. If I have some polynomial f of x and plugging in some value c gives me 0, then that means x minus c is a factor of f of x. And when we're factoring big polynomials later in this chapter, this is going to be something that's really useful for us. The factor theorem also tells us that if x minus c is a factor, then I know that it'll equal 0. F of c will equal 0. All right? And that's the end of part 2 of chapter 2, section 4.